Hello, and welcome to my very first Nextjs ethers um, and whatever tutorial. So, in today's episode, we try to rebuild what Aave did for their tracker of migrated land to Aave tokens. So, what we do here is reading from the blockchain and client rendering this data, and then later we server-side enhance it. There are different approaches you could do here. Like the most commonly used and the one used here is I'm reading the data directly from the blockchain. And if you reload the page, I'm not sure if this works in the stream, but you can try it at home. You'll see that it initializes with 0, and then as soon as the data arrives, it goes to 41.8%. And when the data updates in the background, nothing will change here. Actually, it will stay till next time you reload the page. So what we will do is initialize this data with somewhat accurate client-side, server-side data, and then we'll refetch the data on the client and then subscribe to changes on the client side. Another hybrid way of doing this, and I think we do it in another tutorial actually, is not fetching this on the client at all, but going through like a lambda function to get the most up-to-date data. This has the benefit of not needing big number JS and ethers at all on the client, reducing your bundle size tremendously. So what I did here, just to bootstrap this application and save us some time, is I created a Nextjs application with the yarn create next app command. I initialized it with Tailwind, CSS, and emotion. You can use whatever you want, like the Tailwind extension allows me to write stuff like this to center align our components. I initialized it with some state. I called it very generically a value and that value. Initialized it with 0 and added a progress bar which shows the value. And I also set a max here, which is the supply of land tokens which exist. So if all the tokens were migrated, we were at 100%. And I got this number from the land token tracker. As you can see, it would have some decimal digits if you wanted to be 100% accurate, but in the migration 100 land are migrated to 1 Aave, so we lose some precision anyways, and it doesn't really matter. So I went with the non-decimal number here. Yeah. Besides that, I added a migrator file, which basically holds the migrator contract. It's an address and an ABI. We can get this data from the Aave documentation, actually. So there's a land to Aave migrator contract. And when we look into this, you can see there's a view called total land migrated, where we could fetch the actual number of migrated land right now. This proxy contract, so we need this address, and when we click here, we go to the proxy contract, and there's the ABI we can use to actually fetch the data. And there's one other helper function I already added. I call it use ethers, and it basically holds two functions. One we don't explicitly use in this tutorial, but we need it later, so I added it right away. And one we can use as a hook to get ethers provider. So SSR ethers creates an inferior provider. It doesn't specify any API key or similar, so we use the free one for the sake of this tutorial. And use ethers is a hook which returns loading and provider, and when loading is false, the provider will be set and we can use it. So what we do here is basically using our SSR ethers function and it returns a promise with the provider, and when the promise returns, we know that the provider is ready and we set loading to false. That's all the magic to it. One other thing I did here is I renamed index.js to index.tsx. This will automatically prompt Nextjs to tell you to install TypeScript dependencies. I just like the automatic complete from TypeScript. So I added this in the mix here as well. And I added the eaters library. So with this done, we can actually get started reading from the blockchain. So what we can do here, just to see if it works, is create a use effects function and get our provider. So loading and provider. And then we can say if not loading, we can use the provider and fetch some data. And we want to rerun this hook on changes of loading. So what we can just do to test if things work is take the provider and fetch, for example, the current head block. Provider get block number, and that's a promise. So we just set value then, and the result will be passed to set value. And if we look at this, yeah, it works, and we can see this is the current head block of our provider. So to actually fetch the data from the blockchain now for our interface, which just renders this progress bar, we have to instantiate this contract. So we say const contract equals new contract, and the first parameter is the address, the second parameter is the AVI, and the third parameter is the provider. So with this at hand, we can actually do contract and then directly read this function here. Autocomplete for this doesn't work for me, so it's total length migrated. Again, it's a promise, so we should be able to do set value, but this will result in an error now. And that's because total length migrated is a big number. Okay, it doesn't result in error. But we want it to be readable. So length token is an ERC20 token. It has 18 digits. So what we can do here is use the utils helpers from eaters. And there's one function called format unit, I think. Format units. And there we can just set 18. Oops, not set value. Sorry, so value. I forgot to set it actually. So let's set value. Around this. And format units returns a string. So there's a type error now. We just use number pass float per pass float to make it a float. We lose some precision, but there's more precision than we ever needed for this kind of interface where like the decimal places are not super important. And with doing this, we can actually use this to local string. So like it was already there, but it didn't take effect because value was not a number. But now as it's a number, we'll have decimal points and yeah, looks like that. So that's basically already it. So we now have this progress bar and it shows like the 41.8%. We actually also have the exact number of migrated land, but now when we reload this, I'm not sure if you can see this in the stream, but there will be like a flash of the 0, and if you look into the page throws, you will also see that progress is initialized with 0 here. That's not super important, but if you care about like SEO and stuff, you want to actually render the data appropriately on the client on first sight. So what we can do here is utilize a function of Nextjs, which is called getStaticProps. So export function getStaticProps. And what getStaticProps allows us to do is return some props. And these props are passed to the client on build. So we could initialize like a migrated land, we call it, with 100. So this is a prop coming in here now. So, and we could initialize it here with migrated land, and now it will no longer render with 0 in the beginning, but with 100. This doesn't make sense, of course, but what we can do instead is use our SSR provider here, so const provider, so, headers, weighted, and then we should put this into a utility function, just not do it for the sake of this tutorial. But now we can do exactly the same thing here, but instead of doing the set value stuff, we can just say const value equals a weight, new contract, and let's just throw this away, and then this should work. And now we have on the server side, not on the server side, but on build time, we have the same data as we have on the client. Now that's fine for this use case, but as soon as we deployed this application somewhere, this static data for initializing will be outdated. Like tomorrow, perhaps not 543 million, but 600 million will be migrated, and so the data will get more and more inaccurate. So what Nextjs provides here is a parameter called revalidate. And we could make it 20 or something. And now whenever a user hits the page and the data is more older than 20 seconds, he will get the old data, but in the background there will be a revalidation triggered, and the cache will be invalidated when deploying this on Vercel, and a new static page is generated. So when the next person hits the page, it will get more accurate data. And if you have a lot of users, like it will be almost accurate. So now we solve this problem, but the other problem I said, like when the number of migrated tokens changed, this data here won't update. Like we can reload this and check if it actually happened. So 41.8 it was. It's still 41.8. But there might be cases when this number has jumped and it didn't jump in on the client side. So what we can do here is just subscribe for events here. And there's a contract on listener. And there we can put in contract filters whatever our API defines as events. So if we check for event, there's an event called land migrated, which is actually the thing we're interested in. So we can filter for land migrated and then trigger a callback. And this land migrated function will actually hold some information, like on how many land have been migrated. But as we might miss events, like when the tab is in background or stuff like that, I guess it's more secure to just like refetch the data whenever this happens. So with this, on every land migrated event, the data here will automatically update. And that's actually it. That's everything I wanted to show in this tutorial. Next time, or in the next part of this series, I guess, we create an API function to provide this data via an API, so we can remove all this either stuff from the client side, because when you build this via yarn build, you see that like our bundle size will be around about 200 kilobytes, and that's because ethers is pretty big. Like it includes implementation for big decimal, for the communication layer between the blockchain and your client side, and a lot of other utility functions and stuff like that, which we probably don't need and want on the client side. We don't really care like how accurate the data is. Like if it's 10 seconds old or 20 seconds old, that's still good enough. That's not deep breaking in some ways. So what we can do is drop all this from the client side and make a cached server-side function, like a lambda function or similar, which gets also cached data and passes it to the client. But that's what we do in the next tutorial. Let's just wait till this build finished, so just to prove my point of the 200 kilobytes, so I didn't lie. Yeah, but it should be around about this, yeah, 195 kilobytes. Okay, have a nice day and see you in the next video. Bye.